Hello everyone. Let's take a look at LeetCode 32, longest valid parentheses. It's a very good problem and it can be solved by multiple solutions. For example, we can solve it by dynamic programming, or we can solve it by stack. Okay, let's take a look at this problem. So the problem is given a string containing just the characters, the open bracket and the close bracket. We need to find the length of the longest valid parentheses substring. For example, in the example 1, the longest is 2. In this example, the longest is 4. In the last example is 0. Okay, let's go straight to the solution. First, we can use dynamic programming. DPI means longest valid parentheses ending in index I. So the result is the maximum of all the DP elements. Okay, let's start with the framework. So we have a DP vector and we maintain a result. Finally, we return the result. And we need to for each every character. And in each iteration, we update the results. So this is the basic framework. Let's see how can we calculate each DPI in this box. Okay, so for each character, we only care about the closing bracket, right? Since if it's open bracket, if the string ending in an open bracket, then it must be invalid. Okay. Now, for each closing bracket, there are two cases. Like for current I, if it's an open bracket, then we take a look at I minus 1. There are two cases. One is open bracket, one is closing bracket. So first, we talk about the open bracket. What if it's an open bracket? Then we know it's a closing bracket. So itself is a valid parenthesis. Then we take a look at I minus 1. So in this case, I minus 1, we know the value is 2. So 2 can add the, like 2 can add another 2 here. Since currently we create a new valid parenthesis, which has length 2. So DPI is 2 plus DPI minus 2. Okay, what if DPI minus 1 is a closing bracket? Let's say in this case, DP1 is 2, and DP4 is 2. We need to calculate DP5, assuming I is at 5. Like, how can we calculate it? So to calculate DPI, first, we know that DPI minus is 2. And we have an index, which is I minus DPI minus 1 and minus 1. So this is our index. If DP index is open bracket, then we know this is open bracket, this is closing bracket. So they create a valid parenthesis, right? So we have a valid parenthesis here. And we need to take a look at DP index I minus 1. If they can also contribute the length to our valid parenthesis. So in this case, as long as index is not a negative number and S index is an open bracket, then we know that this DPI is 2 plus, where is this 2? This 2 is the closing bracket and it's an open bracket, plus DPI minus 1. Where is DPI minus 1? DPI minus is this 2. So these characters inside the new open closing bracket, and plus our DP index minus 1. So for the previously valid string, they can like concatenate and combine and generate a longer like substring, right? So this is DPI. Okay, this is a DP solution. Let's take a look at another solution using stack. And first we create the framework. We have stack and we push -1 first. And later you will see how this -1 works. And we have a result. We will maintain result in this hidden box, and we return the result. Okay, as usual, we iterate every character in this input. First, index is 0 and its open bracket. Then we push 0 to our stack. Next, it's closing bracket, which matches the top element in this stack. So we pop the stack. We update the result. Result is I minus stack.top, so which is 1 minus -1. So it's 2 here. Okay, next we add index 2. It's an open bracket. Then we push it to stack. Next, open bracket, push it to stack. Next, it's closing bracket, which matches the top element in stack. So we pop the stack, and we update the result, which is also 2. Next, index it at 5 is also closing bracket, which also matches the top element. So we pop the stack, and we update result. So now result is 5 minus -1, which is 6. So which is our answer. We get the correct answer. Let's see how to implement. So we get the top element in stack. As long as it's a match, so count is a closing bracket, and the top element is open bracket, then it's a match. So we pop the stack and update our result. Otherwise, we just push the stack. So compared to the DP solution, the stack solution seems a bit cleaner and a bit maybe better. But there are also good solutions here, since and the time complexity is same. They'll take ON. Okay, that's a problem. See you next time.